So, uh, hello everyone. I'm Phil, the technical support engineer of Kehua. I'm mainly responsible for European market. So today I'm so glad to give you a brief introduction about our commercial and industrial energy storage system solution. And before I start to talk about our standard solution, I think it's important to introduce the application background of a commercial and industrial application. So as you can see, because we first know to know the application, and then we can know how does the energy storage system work, and also we can know the operation and the control strategy. And also it will affect the system configuration and also affect the system design. As you can see in the whole electrical system, low voltage system, there is a battery system, the lithium-ion battery system, and also the DC distribution cabinet to combine several battery packs together and connect to the power conversion system. It's a converter to transform direct current to alternating current. And then the PCS is connected, we call it PCS, and this converter is connected to the AC bus. And there is also the load part. And the load is also often divided into different level, like the primary load is relatively some important load that need a continuous power supply. And also the secondary load, which is relatively not important. And also, as you can see, this is a low voltage electrical system. It's 400 watt. And there is a transformer connect the low voltage system to the main grid. And for this application, its name is peak shaving. As you can see this figure, the horizontal axis is time in 1 day. And the vertical axis is output power of the load. So as you can see, in 1 day situation, normally the load level is low in between the evening and the morning. So it's also there is a peak time of the curve peak time, and then if the maximum power of the load exceeds the maximum power, so the electricity fee will be higher than the normal price. So in order to reduce the cost of electricity, we add an energy storage system to provide energy for the load when the load level is high, and in other time when the load level is low, we can charge the battery from the grid to storage the energy. So this can save the electricity cost. And also, as you can see, there is an on-off grid switch. What is the switch function when the grid breaks down? So there is no grid. This switch close, this switch open, and the PCS, the battery system, energy storage system, can also provide energy for the important load to make a normal operation and production. And for the second application, it's time shifting. It's an application to make more benefits from the difference in electricity cost. As you can see, for this figure, it's similar with the last one, but as you can see, the vertical value is electricity fee. In 1 day, there is a 2 times loss. The electricity fee is high. We call it peak time of electricity price. The 2 peak time, and also there is a valid time of the electricity price. And then we can storage the energy from the grid at a low price level, and then we discharge to provide energy for the load when the electricity price is high. So we can make benefits from the difference in electricity costs. And also the third is the distribution system expansion. as you can see, there is a transformer between the low voltage electrical system and the main grid. So normally the transformer capacity is fixed before the first construction. So if your load is bigger than the transformer, so you need to add. You cannot get more energy from the grid because it's limited by the transformer. So in this way, you need to get more energy. So how can do that? You can add an energy storage system to the low voltage electrical system. When the load level exceeds the power supply bottlenecks, the power supply bottlenecks equals to the transformer capacity. So if the load level exceeds the bottlenecks, the energy storage system can discharge to provide for the energy. And also, this is a PV optimized utilization. I think it's popular now because there are so many existing PV systems, and if there is only PV system, you can say if the PV energy is greater than the load, then the extra energy will be injected to the grid. So if the PV energy is not enough, like at night, or if the PV energy is not good, you need to get energy from the grid to supply for your load. But if you have an energy storage system, if the PV energy is greater than the load, then you can use the energy to charge the battery to storage the energy. And then when the PV energy is not enough, or at night, or like in winter, the weather is not very good, the energy storage system can still provide energy for your load to save the electricity cost and to maximize the renewable energy utilization rate. And also there is important part is energy management system to manage the PV system and the energy storage system together. And also this is a microgrid system. This application is usually used in off-grid or some weak grid area, like some island, remote area, and so on. And in this area, there are some different systems, like PV system, the energy storage system, and also there is a wind power system and a diesel generator. And in this system, because there is no grid, so the energy storage system will form the grid. That means that it will support the standard frequency and voltage, and to combine with other like PV system, like wind power system together, and to provide continuous energy for the load. And the second part is our Kehua standard solution based on the application. So the solution one is our S-Cube eStore product. It's an integrated energy storage system solution. It's a whole cabinet. And there are three major features. It's very important for commercial and industrial application. It's safe, simple, and smart. As you can see, because we know lithium-ion battery system is safety is one of the most important factors that we need to consider. So talk about the safety of our eStore system. There are three graded level explosion protection. As you can see, this is a battery cell and the battery pack and the battery cabinet. We have each reliable wire in each battery cell and each battery pack. If the pressure inside the cell, outside the cell is not equal, then the valve can be pushed out and the gas released. And then the pressure becomes normal, the valve push back. So it can balance the pressure inside and outside the cell. Also, it's the same with the battery pack. And also we have a two-graded fire protection system. As you can see, we have 5 battery packs for each unit. And we have a two-graded level aerosol protection system. One level is in the battery pack, inside the battery pack. And another is a system level aerosol system. And also there is a smoke detector to detect the smoke. So if the temperature inside the battery pack or in the cabinet reaches a certain value, maybe about 100 centigrades, the aerosol can release gas to take actions with the oxygen to prevent the system from fire risk. And also for safe feature, we have a grounded fault detection. You can see between the battery pack and the converter, it's a DC side. And from the converter to the grid, it's an AC side. We can detect the ground impedance. If the impedance is less than a certain value, we can send alarm to the controller of the energy storage system. And the energy storage system will shut down the converter to protect the whole system. And also, we have a leakage detection system. This is a leakage detection wire. If the liquid leakage occurs, it will the two wires will have a short circuit. So then it can detect there is a liquid leakage happens, and then they can send alarm to the controller to protect the whole system. And also for the smart point, we know for battery for the energy storage system, the battery is the most important part of it. So in order to extend the battery life and to protect the battery and to let it operate at a most suitable condition, we have an advanced liquid cooling system to manage and to control the battery cell temperature. So because it's a liquid cooling system compared with traditional like air cooling system, we can reach a cell temperature difference less 2 centigrade in each battery pack. And for between pack and pack, the pack temperature difference is less than 3 centigrade. So in the long run, it can extend the battery life. And for the humidity control, we can detect the humidity inside the cabinet. We have a humidity controller to detect the humidity. If the humidity reaches the threshold, then the humidity controller start to work to lower the humidity. And also this can also be set manually on these panels. So it's very easy and smart. And also the third point is simple. As you can see, for this cabinet, the top part is 5 battery packs, and the bottom is a modular power conversion system, and this is a liquid cooling chiller system, and also the local controller to manage all the components inside the system. And because it's integrated energy storage system design, the footprint is only 1.3 square meters. I think for compared with other competitors' solution, we have a higher power density. And for C&I application, it's very important to save the space and because it's a high integrated design, you can see all the components, including the battery packs and the power conversion system, and also the controller and other things, are all pre-installed before delivery. So when this machine is delivered on site, you only need to connect the AC wire and also the communication wire. Then the energy storage can start to work. And for this energy storage system, it's one unit. The capacity is 100 kilowatt and 215 kilowatt hours. But if you want more energy, the system can be easily to be expanded from 1 unit to 5 units. So the maximum capacity of the energy storage system can reach 500 kilowatt and 1,075 kilowatt hours. And there is a master controller to manage the 5 units energy storage system together. And the next is the functions of our product. Because once you know the functions of the product, you can use the product properly to make more benefits, to save more storage, more energy, or save the electricity cost, and so on. So for the functions, as you can see, let me introduce some 3 main functions. One is a zero export function. So this function is describes about the power you got from the energy storage system to the grid cannot exceed a certain value, because we know renewable energy like PV power or wind power is not stable enough. So if much energy is injected to the grid, it will affect the stability of the grid. So we have this function can limit the energy injected to the grid. And for the second point is demand control. That means the power you got from the grid cannot exceed the required value, because as I taught before, maybe it's a limitation about the transformer capacity of the maximum power you can get from the grid. So we have this function. You can limit the power you get from the grid, and you can light the energy storage system to discharge to provide energy. And also the third is a Planck curve. Planck curve means you can set the charge and discharge time as a load demand or as the electricity difference at different time. And the next is four main application scenarios. The energy storage system can be used to time shifting. That means charge the battery when the electricity price is low, and discharge when the price is high. Then you can make the benefits from the difference of electricity price. And the second is peak shaving. That means you can let the energy storage system discharge when the load power exceeds the maximum power limitation, also or by the transformer capacity, also the maximum power limitation. And also the PV self-consumption is an application combined with PV system. If the PV system is greater than the load level, then you can charge the energy from the PV system. So the extra PV energy will be not wasted. And also this fourth point is backup power. That means when the grid breaks down, the energy storage system can also provide continuous energy for your important load. So I think this is the first part. And the second part, we can have the next time slot. Yeah. Thank you.
Maybe some of you has some questions about
Yes.
the first part. Any interest? Yes, I see that there
Yes.
is a rising hand. Yes. Thank you.
I have 2 questions.
Okay.
First of all, this completion regarding fire protection system, it's like comes in a standard, or it's accessories which it's necessary to be done?
You mean this solution?
No, I mean fire protection system in the previous slides. Yeah, this. Yeah. Yeah.
This fire protection is aerosol system. It's a standard configuration.
Standard configuration.
Yes.
Okay, thank you. Another question. Communication with third-party systems.
Yes, we can provide communication protocol or MQTT protocol to the third party to light the SCADA, like the communication center, or like the EMS to manage our energy storage system. It's okay.
Thank you.